our next topic is Ohm's law. So very common law. You have studied about this, I think, in class 10th as well. Okay, Ohm's law. Now, what is Ohm's law? If the physical state of a conductor, that is temperature, mechanical strain, length, etc., remains constant, let me write the statement. If physical, okay, you write it. Okay, I'm telling you. Write in your copy. If physical state of a conductor, let me write myself. Okay. Physical state of a conductor remains constant, then the current flowing through the conductor is directly proportional to potential difference across its ends. Okay, and physical conditions are physical state are temperature, mechanical strain, length, etc. Okay, these things needs to be common. Okay, so this means V is equal to E directly proportional to I. V is equal to I into R. From there we have got this. Okay. Means V by I is equal to R. Okay. If you draw the graph of an I is somewhat like this, then this theta, this angle is theta, and tan theta is R. Means the slope will be R. This is what? Electrical resistance. The resistance of a conductor is basically the opposite. It is the property, you can say, which is there in every material. Okay, this is the opposition to the flow of charge which the conductor offers. Okay, now see, resistance is basically electrical resistance is basically two types. Okay, one is ohmic and another one is non-ohmic. Ohmic is what? Which obeys Ohm's law. Non-ohmic is doesn't obey. Right. Here, the example of this will be PN junction diode, transistor, current through gases. Okay, these doesn't obey Ohm's law. Okay, and one property of non-ohmic conductor is that VI graph is non-linear. We have drawn this graph now. VI. This is what it is linear. But for non-ohmic conductor, okay, uh, this graph will not be linear. It will be parabolic or somewhat some type of curve. Okay. The next thing is uh, your dynamic resistance. Dynamic resistance of a conductor is the ratio of change in voltage to change in current. Means this is what delta V by delta I. Means if this is your V and this is your I, and the variation is somewhat like this. Okay, this is I1, this is I2, this is V1, this is V2. You know, dynamic resistance, it will be delta V by delta I, and this will be V2 minus V1 upon I2 minus. Its unit will be volt per ampere. See, unit of resistance is basically volt per meter, oh sorry, volt per ampere and ohm, right? Dimensional formula you can derive. Okay. So till then, thank you. And in next video, we'll be deriving the Ohm's law. Oh sorry, derivation of Ohm's law on the basis of 3-electron model. Okay, to the use of Drift law.